How big is Airbus A380 really? The Airbus A380 was initiated in 1988 when Airbus, a subsidiary of EADS, recognized the necessity of developing a response to Boeing's dominance of the upper echelon of the aviation market through the Boeing 747. The mega project was disclosed at the 1990 Farnborough Airshow. Designers from Aérospatiale, Deutsche Aerospace AG, British Aerospace, and CASA, Airbus's four partners, were invited to propose novel technologies that could be integrated into this project. A feasibility study committee for a very large commercial transport VLCT was established in 1993 by Boeing and several Airbus-related companies. This was perceived as a limited market that may not be worth the effort of a single company to pursue. Boeing withdrew from the project after 2 years, as they believed that the investment would be unlikely to be recouped through sales in the future. Consequently, they continued to pursue plans to further expand and develop the Boeing 747. Airbus initiated the development of its large airliner, the A3XX, in June 1993. One of the unconventional designs that was proposed was the twin fuselages of two A340 that were affixed side by side. The design was not only significantly expanded, but also prioritized operating cost reduction in response to the Asian economic decline of the late 1990s. This revised design was intended to result in a 15% reduction in operating cost for Airbus. Airbus Industry, which had recently undergone a restructuring, approved the EU $8.8 billion program on December 19, 2000. The A3XX was subsequently renamed the A380. The Airbus type number should have progressed logically to the A350, as the A340 was the most recent Airbus design at the time. The number 8 was selected as the most appropriate representation of the twin-deck design configuration, and as a lucky number in Asia, the target market for this aircraft. Construction of the initial structural components began on January 23, 2002, following the completion of the A380 design in early 2001. Initially, Airbus intended to provide the A380 in two versions. In a three-class configuration, the A380-800 can accommodate 555 passengers. If configured as all economy, the total can be increased to 853. In May 2007, Airbus also provided a configuration with 30 fewer passengers, which extended its range by an additional 370 kilometers, 200 nautical miles. This aircraft has a range of 15,400 kilometers, 8,300 nautical miles, which is equivalent to flying from Hong Kong to New York. The A380-800F, which was intended to transport 150 tons of cargo over a distance of 10,400 kilometers, 5,600 nautical miles, was suspended while Airbus prioritized the passenger market. The cargo concept was never revisited. Additionally, an A380-900 stretch version was in development, capable of accommodating 656 passengers in a three-class configuration or 960 passengers in an all-economy version. The current wing area is already rated for the additional weight that would result. However, additional reinforcement of specific areas would still be necessary. This concept, as we now understand, was also never implemented. According to the Airbus A380 specs table below, the A380-800 is equipped with a standard seating layout that accommodates 555 passengers on two decks in a three-class configuration. This is subject to change depending on the airline. For instance, QanTA's has equipped its aircraft with 523 seats in three classes. The A380 is designed to compete with the Boeing 747-400, which has 49% more floor area, but only 35% more seats, 555 seats. This was intended to provide the airline with additional space for passenger amenities, including duty-free stores, gymnasiums, and bars at their discretion. Certainly, these amenities are all very appealing in the conceptual stage. However, economic pressures have caused a bit of a reality check, and no airline has implemented them to date, except first-class cabins on Emirates and Singapore Airlines. 4 engines, the Rolls Royce Trent 900 or the General Electric/Pratt and Whitney Engine Alliance GP 7200, each generating 70,000 pounds of propulsion, are installed on the aircraft. In February 2004, Rolls Royce delivered the initial Trent 900 engine, which completed its initial flight on an A340-300 test platform in May 2004. The Rolls Royce Trent 900 engine sensor system is supplied by Goodrich, while the Engine Alliance GP7200 sensor system is supplied by Amitech. BAE supplies systems controls, while Hispano Suiza provides the FADEC Full Authority Digital Electronic Control System for the GP7200. The 22-wheel Goodrich landing gear is comprised of 2 under-wing struts, each with 4 wheels, 2 central under-fuselage struts, each with 6 wheels, and a tandem nose wheel. Each landing gear is capable of supporting approximately 167 tons. The braking and steering systems are provided by Messier Bugatti, while the nose landing gear is supplied by Messier Dowty with 350 bar hydraulic pressure. The landing gear extension and retraction system is provided by Smiths Aerospace. The airport runways and aprons are subjected to a burden that is comparable to that of a 747. The proximity sensing mechanism for the landing gear is supplied by EADS, a company located in Linwood, Washington. The aircraft is capable of performing a 180 degrees turn within a 56.5 meters breadth, which is equivalent to the 60 meters width dimension of standard runways. With the utmost number of passengers, the aircraft has a maximum operating speed of Mach 0.89 and a range of 15,000 kilometers or 8,000 mph. The airport terminal's turnaround time, which encompasses passenger disembarkation, cleaning, restocking, and embarkation for the subsequent aircraft, is a minimum of 90 minutes. The Airbus A380+. A series of updates and enhancements were implemented by Airbus to enhance the A380's appeal to airlines and enhance its overall quality. The economy of operation was the primary objective of these A380+ enhancements. Although there was a segment of the market that benefited from the opulent offerings of deluxe personalized cabins and similar amenities, the A380's capacity to transport a significant number of passengers at a relatively low cost is a compelling argument for its use. Airbus anticipated a 4% reduction in fuel consumption and a 13% reduction in administrative costs per seat through various modifications. Therefore, what is the A380+, and how does it differ from the current A380? Aerodynamics is the initial consideration. The A380 may be perceived as somewhat peculiar due to its lack of winglets upon its introduction to the market. Winglets can increase lift without significantly increasing the wingspan. The necessity for wider terminal areas at airports is a significant additional overhead, as a result of an excessive wingspan. Of course, the reduction of fuel consumption is significantly influenced by the generation of additional lift. The winglets share a design with the Boeing 737 MAX's divided configuration, with the larger upward-pointing winglets uplet measuring 3.5 meters and the downward-pointing winglets downlet measuring 1.5 meters. This additional lift also provides the capacity to transport a greater amount of payload. To achieve this objective, Airbus is enhancing the available deck space in the passenger compartment by optimizing the functionality of the fore and aft staircases to reduce their footprint. Consequently, the elegant arching staircase at the rear has been eliminated. Additionally, the receptacles located beneath the windows will be eliminated, thereby increasing the cabin's width. The enhanced lift will allow for an increase in the maximum takeoff weight (MTOW) to 570 tons, which could be equivalent to flying an additional 80 passengers or traveling 300 nautical miles beyond the current range of 8,200 nautical miles. According to Airbus, the average seat configuration selected by airlines is 497 in total, and this figure could increase to 575 in the A380+. Emirates has been exerting pressure on Airbus to produce a new engine option version of the A380. However, Airbus was hesitant to incur substantial development expenses during the aircraft's weak sales. The A380+ features contributed to the economic savings that airlines were seeking. However, they were insufficient to maintain the A380's relevance in the current market, as we now know. Compared to the Boeing 747-400, the A380 Airbus interior features twin-aisle accommodations on the upper and lower decks, resulting in a 35% increase in seating capacity and 49% more floor space. There are 555 seats available in a 3-class configuration. A typical upper deck layout comprises 96 business class seats and 103 economy class seats. The main deck is equipped with 334 economy class seats and 22 first class seats. The passenger levels are connected by 2 stairwells. Limited mobility commuters are granted access via a lifting system that operates between the passenger decks. Additionally, the 2 passenger platforms are connected by a cargo hoist. The Airbus A380's bulk enables the implementation of numerous passenger facilities and configurations. The Singapore Airlines launch customer aircraft is configured to accommodate 471 passengers. The main deck features 311 economy seats and 12 first-class suites, while the upper deck contains 60 business class seats and 88 economy seats. Each airline customer will inevitably select their own cabin configurations, furnishings, and colors when they order their version of the Airbus A380. Airbus has demonstrated some of the most recent developments in aircraft interior design and technology, resulting in a sense of spaciousness and vitality. Don't forget to like, subscribe, and hit the notification bell so you never miss an update. Your support helps us keep bringing you amazing content.